everyone. In this video we're going to talk about solving compound inequalities. Before we talk about that, let's just go back to something we did a couple of weeks ago, and that is in domain and range. We did things from least to greatest, and the domain were the x's and range were the y's. How this connects to what we're doing now is I showed you that we write our domain and range as inequalities, with the least number on the left, greatest on the right. Let's make note of this. We use inequalities like 4 is less than x, which is less than 9, and negative infinity is less than y is less than positive infinity. There's a name for this type of inequality, and it's not just an inequality. This one has a special name. That special type of inequality is called a compound inequality. Let's get the definition for that. A compound inequality is an inequality that has either upper and lower boundaries, or it's the combination of two separate solution sets. And I'll show you what separate means in just a moment. Before I do that, let's make sure you understand what these boundaries mean. If there are both upper and lower boundaries, then our solution set is within the intersection, which is the same thing as just the overlap of those two inequalities. So if they overlap, if the two inequalities overlap, that means we call it the intersection. If two inequalities do not overlap, then we call their compound form a union of two inequalities. So the two types are either they do not overlap and they make a union, or two inequalities overlap and they make an intersection. Let's do number 1 as an example. We have b is greater than 3, so we can't be equal to 3. And we have b is less than or equal to 0. Less than or equal to. So we can be 0, so we're going to put a closed dot. b is greater than 3 means we can be the numbers to the right. b is less than 0 means we are the numbers to the left. Are these two lines going to overlap? No, they're not going to overlap. They're going in opposite directions. So two non-overlapping inequalities mean that we have a union. Let's check and see what this next one is. K is greater than 1, so we can be numbers that are bigger than the number 1, and K is greater than 5. K is greater than 5. Alright, so we can be numbers bigger than 1, and we can also be the numbers bigger than 5. So these two are going to overlap. They will overlap. There's a hitch. So since we can be the numbers, all numbers greater than 1, but this is like a but. K has to be bigger than 5. So since we are doing the compound, it doesn't say either one, it says and, so that means that there's a but. So we only want the answers that are greater than 1, but are also greater than 5. So then the actual solution set are only these ones. The intersection is only the ones that are greater than 5. So that's the solution set to that compound inequality.